Okay, so today we're going to do two things. We're going to take some notes on solving systems of linear equations by graphing, and then we'll get started on the assignment. And both of these things are going to be done on Kami. So what I need you to do, and for those of you at home, you're going to have to do the same thing. Go to where it says Notes Solving Systems by Graphing. So look for that. It's Notes Solving Systems by Graphing. And as you can see, it says complete the following notes using Kami. Be sure to submit your completed notes by January 3rd, which is tomorrow, or January 20th, Thursday. So we're not going to complete them today. We're going to do a second round in these notes tomorrow. So you can turn them in after that. All right, so let's get into Kami. And this is what we have. This is the notes. And it's solving systems by graphing. And it's what we're going to focus on the rest of this week. Okay? So I'm going to zoom in. I usually go 200. And that may be a little bit too much for this. So let me go 150. Okay. Perfect. All right. So we're going to be solving systems by graphing. So yesterday we learned that a system of linear equations is when you have two or more linear equations or lines on a graph. So we want to start thinking of everything in terms of two lines when we graph two lines, okay? So it says when solving a system of equations by graphing, the solution of a system of equations is the point of, well, where they meet. So we're going to say it's the point of intersection. So I'm going to go to, maybe 14 is too big. I'm going to go here. Maybe red is the color I want. So go to text. And over here where this blank is, I'm going to write the word intersection. Intersection, okay? So the solution to a system of equations is the point of intersection, where two lines cross and meet, basically. That point is the solution, we call it. So I want us to brainstorm for a bit. Think of what happens when you have two lines. And I want you to also keep in mind that when two lines cross, that point, that dot where they cross, that's called a solution. So the first thing I want us to brainstorm and maybe come up with a thought about is, would it be possible to have a system of equations that has no solution? And if there is, what would it look like? So is it possible? So two lines crossing, basically one of these, some way, somehow. That point where they cross, that's a solution. And everywhere the points touch from two lines, we call it a solution. Is it possible that there's no solution? Yeah, there is. What would it look like?
Two straight lines?
Yeah. Everyone's showing me this. And they're parallel. Because we all know that two parallel lines never touch. So if we're saying where the lines touch is a solution, well, if they never touch because they're parallel, no solution. So yeah, that's exactly it. So let's go over here and type something up. So let's say yes to the question and explain. Okay. So we could say if the two lines are parallel, then they will not meet, touch, intersect. What do you guys want to use? Intersect. So there is no solution. Boom. Good brainstorm. All right. So that's the first one. Let's look at the next possibility that we want to explore. Um, okay, so would it be possible to have a system of equations with infinitely many solutions? So let's talk about what infinitely many means. Remember, if the two lines touch at one point, then there's one solution. So infinitely many means infinitely many touches. Yes.
What if the equation is the same, so it's the same line, so technically it would be
Overlapping. That's exactly it. If technically, and I like the way you said that technically, because it is going to be a technicality when you see it. Um, it's the same equation. So if the two lines overlap, then they touch in every point. And in theory, how many points are on a line if it goes on forever? Infinite points. So infinite solutions. Okay. So let's answer that one. That's also a yes. Um, sometimes they say that the two lines coincide, overlap. If the two uh, lines overlap, then they intersect infi- infinitely many times. So infinite solutions. I think I'm kind of hung up on grammar, so I'm going to put a comma here. I noticed I needed a comma here after before the then, or after. Actually, it should be here after the then, not before. Okay, so I'm giving you guys a chance to catch up. I'm noticing some people still typing, so. Okay, you guys ready to move on? All right, so let's look at three possible outcomes. When you graph two lines on a graph, in other words, a system, there's three possible outcomes. Three possible things are going to happen. One of them almost always happens, and the other two are rare, but they do happen. And we just actually talked about them. So the table below describes the characteristics of the types of solutions on a graph. So the first one is what's mostly going to happen, like let's say 99% of the time. Okay? This is where we have one solution. One solution. Okay? One solution is two lines intersect just once. So let's talk about what, in terms of the slopes and everything, what we should be looking at. So lines have different slopes. So if the two lines have different slopes and intersect at one point, so as you can see here, we have one line with a negative slope, it's going downhill. One line with a positive slope, it's going uphill. Those are different slopes. So they're going to meet at some point. Okay. And they only meet once. Any questions? All right, let's look at infinitely many solutions, or I'm sorry, no solution. This is what it looks like when you have no solution. Obviously, we already talked about this. No solution. So you have parallel lines, basically. So lines have the same slope. In order for two lines to be parallel, they have to have the same slope. And the other thing is they have to have different y-intercepts. So we're going to start looking at slopes and y-intercepts. Okay, so here's what I want you to do. I want to emphasize the fact that they have to have different y-intercepts. So we're going to mark that up. We're going to highlight that. So after you wrote the word slope here, go to markup. So let's all go to markup. And this is like a highlighter if you haven't used it. Pick your favorite color, whatever color you like to highlight with. I'm kind of liking, well, I'll do the yellow because it's kind of, I like the box highlighter. Pick this one that says box highlighter. And we're going to highlight different y-intercepts. Ooh, that doesn't pop that much. I changed my mind. I'm going to change the color. Red. There we go. That's better. Different y-intercepts. So in order for two lines to be parallel and give us no solution, they have to have the same slope and different y-intercepts. Okay? Any questions? All right. Let's move on. And now we're going to talk about infinitely many solutions. Let me go back to text. And over here at the top, we're going to write the word infinitely many. Infinitely many solutions. So in order for this to happen, basically the lines have to overlap. It has to be one line overlapping the other. And this is going to happen when the lines have the same slope and the same y-intercept. So I'm going to go back and highlight same y-intercept. So I'm going to go back to markup and just highlight same y-intercept. All right, so we're going to start looking at graphing lines. So we are going to look at what's the slope number, what's the y-intercept number, and use that information to graph. Okay? So you guys ready? All right, so what we're going to do is we're only going to do for today, we're only going to do graphs 1 and 2. The rest of this, starting with rewriting linear equations and then graphing when we do that, all of this stuff, we're going to do all that tomorrow. So this is all for tomorrow. The only thing we're going to finish up with today are these two graphs. Okay? So let's do that. So we're going to solve a system of equations by graphing. All right. So here's the deal, guys. This is a system. We have two linear equations. Luckily for us, they did most of the work for us in that both equations, both of these linear equations, are in slope-intercept form. That's the easiest way to graph a line, right? So what we're going to do is figure out what's our slope number, what's our y-intercept number, and use those to graph. So our first equation is y equals 1/2 x plus 1. Okay, so let's see. Hasn't been too long since we did this. Yeah, well, day before, Friday, maybe. But where's our starting point? What's the y-intercept number? Remember, let's review the number being multiplied with x. I think you're confusing it with the slope. The slope is 1/2. The number multiplied with x, the coefficient of x, that's a slope, the steepness of the line. The constant, the number that we add or subtract, that's the y-intercept. That's a number we want to start with because that number happens, the y-intercept number happens when x equals 0. So if I replace x with 0, what's 1/2 times 0, guys? 0. What's 0 plus 1? So that's telling me start at 1. So remember, the quick way is see what number is being added or subtracted and that's the starting number on the y-axis. So we're going to start at 1, okay? So let's go to 1. Pick a color, go to drawing, and pick a, maybe that might be too big. So I'm going to go to this one. And so everyone can see, I'm going to zoom this up maybe to 200 now, so I can just focus on this one graph. Okay, so here we go, guys. I'm going to go to drawing, pick 4 for the thickness, pick a color, and go to the y-axis, go to 1 on the y-axis, or 0, 1. And that's our first point. Yeah, I changed my mind, sorry. 6 was better. I want big chunky points. So let's try it again. I pick 6. There, that's better. Okay, there's my first point. And now I'm going to use the slope, 1/2. So from here, using the fact that it's +1 over +2, how do I find other points on the line? Up 1 to the right 2. Simple as that. And do that several times. For this, I recommend you make as many points as possible, but because one of these points you're making is going to be the point where the line intersects, and at this point we don't know which one it is. Okay, so I just got that half. What I'm going to do is I want to find the other half. So I'm going to go back to my original point. Instead of up 1 to the right 1, do the reverse. Yes.
Well, I think for everyone, for me, they're uneven, like the line.
The lines?
Yeah. For the graph.
I'm not sure. Hold on. So you can go down 1 to the left 2. Let me take a look. I want to see what you're referring to here, Carlos. Okay, you want to zoom up. You have this at 100. It's going to be better if you zoom. Yeah, there you go. Yeah, you want to zoom up as much as possible. Yeah, guys, make sure this zoom is at like 200. Okay. Yeah, make sure this zoom here, for those of you at home, is also at 200, 150, 200, somewhere in there. Okay, so again, I'm going to go from here. I'm just going to make points going down 1 to the left 2, all the way across. Okay. Notice I made all of those points because I don't know which one the 2 lines are going to meet at. Okay, now let's make our line. For the line, go to shape. I'm going to match up the color, that color purple. And the thickness, I guess 2 should be great. 2 will be fine for that. And then we're going to make a line from one end to the other, all the way across. Okay, kind of just wiggle it till it, and I'm a little bit of OCD on this. So I'm going to go to select, grab the select arrow, and grab my line and just kind of wiggle it so it's just perfect there. And then you can always readjust after you make your line. Go to select, pick the arrow, grab whichever end you want to fine tune, and just make your perfect line, because one of those points is going to intersect. Okay, that's our first line. Now let's talk about our second line, the slope and the y-intercept for this line. Okay, let's start with a slope. So for this second line, it's y equals -x plus 7. The number in front of x is my slope. What number is in front of x, guys? Help me out. -1. As a fraction, because I want to rise and a run, what number would it be? -1 over 1. So I'm going to say the slope is -1 over 1 for that second line. What happened? There we go. Okay. And then I'm also going to say the slope, the b value, remember the m and the b? the y-intercept is the b value. That's going to be 7. So I'm just going to write that to remind me. That's my starting point. Okay. So I'm ready to make my second line. Pick a different color if you like. I'll pick red, I guess. Okay. Where am I starting my second line? At 7, because it's plus 7. So right there. And then the slope is -1/1, so you go down 1 to the right 1, down 1 to the right 1. And make several points because one of those will cross, and I think I already see where it's going to cross. So just keep on going down 1 to the right 1. And right there. So I'll just make that point right to there. So it looks like it's going to cross at 4, 3. 4 across, 3 up. Okay, but let's make our line. So go to shape. I'm going to pick that same color red and make your line. Right about there. Okay. And so my solution is at this intersection point. So I'm going to type in the coordinates for that. And it's 4 across, 3 up. So I'm going to say 4, 3. Where it's asking for the solution, it's 4, 3. And I'm going to put it over here too. Okay, 4, 3. So the solution is 4, 3. If I were to plug in 4, 3 in for x and y, it would give me true statements in both equations like we were looking at yesterday. Let's just finish up this one, okay? All right. Let's move on to the second line. You guys ready? Okay. So let's take a look at y equals 3/2 x. That's the equation. So where's that one going to cross the y-axis? What's the b value? 0. Here's why. If I really wanted to, if I need to, I could always type in plus 0, right? Is that going to change the equation? No. But it tells me the y-intercept value is 0. So let me grab my drawing tool. Go to 0, 0, or 0 on the y-axis. We call it the origin. That's where it's going to cross. Now use the slope, 3/2. So that's telling us you go up 3 to the right 2. Up 3 to the right 2. Okay. And so it looks like I have that many there. Go back to your original point, and then we're going to go down and to the left. Down 3 to the left 2. And do that a couple more times, I guess. There. So those are all the points I can fit for this line. Let's make our line now. Go here and let me switch a color. Okay, I'm gonna fix the bottom. Just gotta wiggle, 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 and fix this. There. Good. Okay. There we go. So there's our first line. Let's go to our second line. Our second line, I'll pick color red. And let's see, where is this second line going to cross the y-axis? -2. It's y equals 1/2 x minus 2. So at -2 on the y-axis, this is where we start. The slope is 1/2. So it's positive. So you go up 1 and to the right. And we'll continue to do that. Looks like it's going to cross somewhere down. Right there. This very next point is where it... Okay. So it looks like it crosses right there at -2, -3. -2, -3. Perfect. So let's make our line. And we'll type in the solution. What did we say? -3, -2? Oh, other way around. -2, -3. Yeah, the x value is -2. There we go. That goes there, and I'll put it here where it asked us to put the solution. So that's the solution for this one. Okay. So this is what we're going to do on today's assignment, which is also on Cami. So I'll give you a minute to catch up with this. Then we're going to switch gears. Do not turn this in yet. We're going to finish this up tomorrow. So just leave it be, and we'll come back to it for the notes tomorrow. Okay? What I need you to do now, is everyone done with this? Can I switch pages? Okay, let's go back to Schoology. And the assignment is solving a system of equations by graphing. It's also a Cami. And again, I'm going to have to zoom it because it's at 100 and not... I'll go to 200. That should work. And basically, we're going to repeat what we just did. We're going to graph the pair of lines and then figure out where they cross and write that as a solution, okay? So let's just do one together, and then I'll let you go. Okay, so we're going to start with y equals -5/3 x plus 3. Let's begin. Our first point is at +3. So right there. Then we're going to use the slope. So the slope is -5/3. Tell me, what am I going to do first, guys? If it's -5/3. Do I go up or I go down? Yeah, I'm going to go down 5 and to the right 3. So the points are going to be pretty spaced out. And that's basically all the points I can fit, just those 2 points. So make your line with those 2 points. My guess is one of those 2 points is going to be where the 2 lines meet. Okay. So there's my line. And let's go ahead and graph our second line. This line is going to cross at, it says -3. So that's on the y-axis at -3. And then our slope is 1/3. So that tells us to go up 1 to the right 3. So there is our point of intersection. I'm just going to go maybe put one more to make a nice, neater line. So there's my 3 points. And here's my line. Wow. I got to fine tune this line a little. I go to select and grab one end and then just kind of wiggle, wiggle, wiggle. So it looks a little neater. There, that's better. Okay. So what's my solution, guys? What are the XY numbers for the solution? 3, -2. So let's write that in the text box or make a text box. Solution. Parentheses 3, comma, -2. Boom. We're done with number 1. Okay. And for those of you at home, you need to do the same thing. Make sure you write down what the solution is, okay? Let's try another one together and I'll let you go. All right, so let's go with the second one. We're going to cross at 3 because it's plus 3. The slope is 4. So what should, if the slope is 4, as a rise over run, it would be 4 over what? 1. So you go up 4 over 1. But do you notice I can't go up 4 spaces from this point? So rather than go up 4 to the right one, we're going to go down 4 and to the left one. So go down, go 1, 2, 3, 4, and to the left 1. So here's a point that's part of that line. And then do the same thing. 1, 2, 3, 4, and to the left 1. Right there. Okay, so these 3 points are part of that line. Let's make this line. Like that. Okay, so our first line is done. Go to make our next line. Okay, so this next line is going to cross it. It says -2, so that means -2 on the y-axis, right there. And again, this is a slope of -1. So that's -1 over 1, so that tells us go down 1 and to the right 1. But obviously, we want to put points the other way. In fact, this is going to be the point where it crosses at -1, 1. I'm sorry, -1, -1. Yeah, the solution is -1, comma, -1. Okay? So let's make our line here. Like that. Okay, and the solution is -1, -1. Okay. There it is. All right, so if you're at home, continue working on this. This is the actual assignment. When you're done, make sure you turn it in, and this will be for credit. The notes will also be for credit, but we will complete those tomorrow. Okay? Bye.